Let us see what the Solow model is. The Solow model is a workhorse model to understand growth and business cycle. It is developed by the Nobel Prize winner Robert Solow. So we start off with the production function y is equal to function of a, k, and l. This production function shows that output is produced by the combinations of technology, capital, and labor. So for the ease of our assumption, we assume that a and l are constant in this production function, and therefore we derive another production function, that is y is equal to f of k, that is output is a function of capital. And further, we assume that there are some properties to this function, that is the more capital we include, the more output it produces, but only at a diminishing rate. That is, there is diminishing marginal returns to capital. So as to satisfy this assumption, we take the production function and modify it into y is equal to root k. Therefore, this particular production function will satisfy all our assumptions uh, that we require as a prerequisite to develop this model. This is the production function represented in a graph. As you can see, y-axis shows output and x-axis shows capital. You can understand that this graph represents a diminishing function, that is, with more input, less output is obtained, and this is the graph for y is equal to f of k. The graph for y is equal to root k will follow in this session. So the question here is, what does this model imply? So this model implies that since there is diminishing returns to capital, countries with small capital stocks should grow rapidly. Okay, so this model assumes that if a country, say Belgium, has limited capital stocks or lower amount of capital stocks, then there will be then Belgium will grow rapidly, and as per this model, Belgium will slow down when its capital stock increases. So the question we should consider here is, then why does not all these poor countries are growing rapidly, not growing rapidly? So to understand that, we should understand another important concept that goes by the name conditional convergence. So what is this term? Let us look into it. So, conditional convergence is used to refer to how poor countries tend to grow faster than rich countries, converging to similar levels of income. That is, as we know, the Solow model predicts that when the country's capital stock is less, it grows rapidly and will be at par with or in the same pace with other developed countries. So, the conditional convergence shows that uh, the conditional convergence applies to countries with similar institutions. That is, the only condition there is not that of limited capital stocks, but that of similar institutions. To get the same advancement with the developed countries, the lower capital country should have similar institutions as that of the developed country. Only then will they achieve this growth rapidly. Okay, so this particular concept comes under the term conditional convergence. So this is an important concept to understand the Solow model. So the next important concept we should uh, look into is the investment consumption. So as you can see in the graph, the green line represents investment curve. It is obtained by the function I is equal to zero point 0.3 y, and as we have already discussed, we take the production function y is equal to root k. Therefore we can write or rewrite the function, the investment function, as I is equal to zero point 0.3 root k. So let us see what this particular graph or what this particular investment curve implies. So just look into it. So this graph shows that when the output is 10 units, the capital we should use is 100 units. And so as the graph shows that out of 10 units produced, 3 units is invested and the remaining 7 units is consumed. It's easy to understand. That is so simple to understand that When the capital is 100 units, we derive an output of 10 units, and out of these 10 units, we must invest 3 units, and we can consume only 7 units for our sustenance. The next important concept we should understand is that of capital depreciation. Depreciation means wear and tear. So on screen you can see depreciation definition. Depreciation means decline in the value of fixed asset due to use, passage of time, or obsolescence. So let us bring the concept of depreciation into our model. So as you can see, the red line shows the depreciation, and the function is d is equal to 0.02k. Okay, 0.02k, that's what the function is for depreciation. This means that if there are 100 capital units, then 2 units wear out, or 2 units depreciates every year. So let us look into the investment and depreciation graph much closer. So when we look into uh, the depreciation and investment graphs closer, we can see how much of capital the firm can actually use. The green portion shows where investment is greater than depreciation, and the red portion shows where depreciation is greater than investment. In the green area, the capital stock is increasing, whereas in red area, it is falling. You can see at a point there is investment equal to depreciation. This point is called the steady state. At this steady state point, the capital neither grows nor shrinks. At this point, you can invest solely to replace the depreciated capitals. Okay. So in this particular diagram, the steady state is where the capital is 225 and the output produced is 4.5. So as you can see, the steady state output is taken into consideration as the GDP